Welcome back. Today we are going to do some small integration here. We are going to have a simple function and take two ways to solve the problem. So if I take the integral of x over the quantity cubic root of x plus 1 dx, and I will try to integrate it for you. Okay, so there are two ways here. We are going to use both. On the first way, we are going to use a very solid way to get rid of the radicals. So we have a cubic root here. So we have whatever we have under the cubic root, we have to elevate it to the cube root, to the cube, to get rid of the radical. So here we have x plus 1. X plus 1 has to be elevated to the cube, no? To get out of the cubic root. So we are going to find a variable, and this time I'm going to use t, and I'm going to say x plus 1 is t cubed. So that will eliminate my radical, and I will say that gives me that x is equal to t cubed minus 1, and dx is equal to 3 t squared dt. All I have to do is to replace these values, and now if you look at the cubic root of x plus 1, it's a cubic root of t cubed, and that is just a t, right? So denominator, now I don't have any radical, I just have the t. That is very good. Okay, now my integral, primitive integral of x over the quantity square cubic root of x plus 1 dx is equal to, I replace everything now. The x is equal to t cubed minus 1, so it's integral of t cubed minus 1 times dx. Dx is equal to 3 t squared dt. Okay, and I have that, and over cubic root of x plus 1, we found that that's what's equal to t. So I'm going to simplify here, and the 3t squared become 3t, and the t vanishes from the denominator, leaves 1. So now I have a simple integral here of known methods. So what I'm going to do is, I will say it's equal to 3 times integral of t cubed minus 1 times t dt, which I'm going to distribute the 3 and the t on both. I get a 3 times integral of t to the power of 4 now dt minus 3 times the integral of t dt. Okay, so that is simple. Now we can just apply the formula and find the result of this integral. And we know that on the first one we will get 3 times t to the power of 4 plus 1 over 4 plus 1. So that makes it 3 times t to the power of 4 plus 1 over 4 plus 1 minus 3 times t to the power of 1 plus 1 over 1 plus 1, okay, plus a constant. So that means we get 3 over 5 times t to the power of 5 minus 3 over 2 times t squared plus a constant. So all we have to do now is to replace t by its value. We knew that t cubed was equal to x plus 1, so we get integral of x dx over cubic root of x plus 1 becoming 3/5 of t to the power of 5 is equal to, we know that t is the cubic root of x plus 1, correct? Because we say that t cubed is equal to x plus 1, so t is equal to cubic root of x plus 1. Okay, so not the x but the t. There you go. T is equal to cubic root of x plus 1. And we get here, we get 3/5 of x plus 1 to the power of 5 minus 3/2 of cubic root of x plus 1 squared. So I can now just readjust the writing here to make it more legible. So we can say 3/5 of x plus 1. We pull x plus 1 cubed outside and we leave x plus 1 squared minus 3/2 of cubic root of x plus 1 squared. We can also put this cubic root of x plus 1 squared outside and leave just the 3/5 of x plus 1 minus 3/2 to make it a little more legible, but we can leave it as is. Now let's try the second method. The second method is also a good one. So here we are not going to say that x plus 1 is equal to t cubed. We are just saying that x plus 1 is equal to t. And why not? That means dx is equal to dt and x is just equal to t minus 1. Okay, so it works. So what we can do here is integral of x dx over cubic root of x plus 1 becomes, we replace everything now, plug in, and we get t minus 1. The dx is equal to dt, and now all over cubic root of the t. Now we can really break this fraction and have two parts of it, because we have just a simple denominator here. We can say that it is equal to integral of t over cubic root of t dt minus integral of dt over cubic root of t. Okay, so the dt is missing there, but that's fine, it's a typo, so we can continue. We know that cubic root of t is equal to t to the power of 1/3, and also we say that t is t to the power of 1 is also t to the power of 3/3. Make it same denominator. So knowing what we know, we can come back to the t's here, to the integral, and say we have integral of of t to the power of 3/3 times t to the power of minus 1/3 when it goes to the numerator, and the dt. Now minus the second part will be just t to the power integral of t to the power of minus 1/3 dt. And we can apply rules here. If that one becomes 2/3, 3/3 minus 1/3 is 2/3 dt, and minus integral of t to the power of minus 1/3 dt. And we know that we add 1, it will be t to the power of 3/5 actually, because what happens here is it is t to the power of 5/3 over 5/3, but that 5/3 comes to the numerator, become 3/5. The same one for the second one, it will become minus 1/3 plus 3/3, 2/3, so minus 3 halves of t to the power of 2/3 plus a constant. So does that sound familiar now with what we had in the first method? We can finally rewrite it down. Yes, now we have come to this one, and we know that t is equal to x plus 1, and we have to plug in, replace t by its value. So what we get now is the original integral of x dx over cubic root of x plus 1. Now it's becoming 3/5 of t was equal to x plus 1, so cubic root of x plus 1 the 5th power minus 3 halves of the cubic root of t squared. That means x plus 1 squared plus a constant. Of course, solving this, if we get this result, we are already good. This is what we are looking for, but we can put in factors here. We know that 3/5 of cubic root of x plus 1 to the power of 5, we have the 3rd power there, and we leave the x plus 1 squared inside, because 5 is equal to 2 plus 3. Otherwise, is x plus 1 to the power of 5 is x plus 1 squared times x plus 1 cubed. And on the second part, we don't change anything, and we can get this result which is similar to the first one we got, but we can dig deeper now and put in more factoring. If we look at this, we have the 3 times cubic root of x plus 1 squared. We can put it in factor actually. It is cubic root, not square root. We will fix that. Squared here. Now 5 times, on the first part we have x plus 1, of course x plus 1 over 5, minus there on the second part we get only 1/2 now if we pull out the tray. So plus a constant. Now we have to put this in the same denominator, and finally we are getting into a situation where we have 3/10 actually, and as a common denominator will be 10, so we pull out the 10, so 3/10 of cubic root of cubic root here, cubic root of x plus 1 squared, x plus 1 squared, factor in, we put on some denominator 2x plus 2 minus 5, so that means 2x minus 3 plus a constant. Okay, so that is the same as the one we had before, and people don't need to come here, but well, nice to have it that way. So that's it for this one, and thank